Okay, so section 7.4 is titled Approximating Square Root, so let's get in and how to do that. And we'll start with the nearest integer. That's actually what we're just going to look at for right now, is the nearest integer. So when we do that, when we're approximating a square root to the nearest integer, we're going to find the two perfect squares that the number is between, the two perfect squares. So when we're doing, for example, the square root of 71, we're going to think, okay, what two perfect squares would fall between 71? And so if you have your list of perfect squares, we've got, 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. You're going to get to 8 squared, which is 64, and then 9 squared, which is 81. So those are the two perfect squares that 71 is between. And so once you find those two perfect squares, which we said was, square root of 64 and the square root of 81, then we're going to determine which number it's closest to. So the square root of 64 is 8, and the square root of 81 is 9. And so we can kind of see which one it's closer to. We can see 71 is 10 units away from 81, but 71 is only 7 units away from 64. So it's actually going to be closer to 8 as our as our answer. It's going to be closer to 8. So that means it's kind of close though, right? It's in the middle. It's pretty fairly even in the middle. I would say if I had to guess, it'd be around 8.3 or 8.4 would be my guess. And of course, we could use our calculator to confirm that. I wouldn't say it's quite 8.5 because it'd have to be right in the middle, and 71 is not right in the middle of 64 and 81. It's leaning towards the 64 side. So in this first example here, estimate each square root to the nearest, for part A, integer, and then to the nearest tenth. And so we can do the integer part without using our calculator. So I've got square root of 460, and that's going to be between which two perfect squares? Well, one of the advantages, again, to knowing your perfect squares, especially up to 25 squared, is that you would know that it's going to fall between 484 and 441, and that's actually between 21 and 22 is what those would be. So again, just kind of looking here, I can see that 60 is 24 units away from 84. It's 19 units away from 21, so it's going to be closer to 21. And so now, if I'm approximating to the nearest tenth, it's not right in the middle, but it's fairly close. I would say we're probably looking at 21.3 or 21.4, somewhere in that range. And you can use your calculator to double check, but that's how you would approximate it without having to use your calculator. It's going to be somewhere in that range when I round to the nearest tenth. So for part A, I'd say it's closer to 21. And for part B, I'd either say 21.3 or 21.4. And actually, if you use your calculator, you'll find out it's closer to 21.4. It's actually 21.4476, I think, when you round it. So 21.4. Now for part B, this is important to note that this is negative. So as I'm listing my perfect squares, I'm going to consider them negative. And so see how I put the smaller one over here and I put the larger one over here. If I continue that pattern, the smaller one would be negative square root 25, and the larger one would be negative square root 16, and negative square root 24 would come right between there. And that's because I'm on the negative side of the number line. And when I'm working with the negative side of the number line, negative 5 is smaller than negative 4. Now, clearly, the negative square root of 24 is much closer to the negative square root of 25. So part A of this, when it says round to the nearest integer, it's clearly going to be closer to negative 5. And then when I am rounding it to the nearest tenth, I can see it's only 1 away from 25, but it is 8 away from 16. And so it's, again, much closer. So if I had to guess, now remember, it's not going to be negative 5 point something because it's not quite negative 5 yet. It's still going to be negative 4 point something. My guess is to be either negative 4.8 or negative 4.9. And if you use your calculator, you find out it's actually negative 4.899. So it's actually a lot closer to negative 4.9 than what it is to negative 4.8. So that would it be to the nearest 10th. All right, let's look at some problems that involve, again, just approximating square roots here. It says the radius of a circle with an area of A is approximately the square root of the area divided by 3. And again, that's because, it says approximately, that's because when you find the area of a circle, you have to use pi, and a pi is approximately 3. So again, we're just estimating this. And of course, if you wanted to actually write the equation out, you can see where this exactly comes from. So area of a circle is pi r squared. If I want to solve that for the radius, I divide by pi. And then I square root both sides. And so that's where the a over 3 comes from, because it's approximately pi, right? So that's where all that comes from. Now it says the area of a circular mouse pad is 51 inches squared. Estimate its radius to the nearest integer. So if the area of that mouse pad is 51, the radius is going to be approximately 51 divided by 3, and then the square root of that. Now, it may not look like it, but 5 plus 1 does equal 6, so 3 will go into 51 an even amount of times. And so that's actually 17, so the square root of 17. And it wants us to approximate it to the nearest integer. So I know that square root of 17. And again, I'm just thinking my way through this, right? I know that's between the square root of 16 and the square root of 25. And I know 16 and 25 are both perfect squares. So it's between 4 and 5, much closer to 4 than what it is to 5. By the way, this is what I would want you to show for your work then, is this part right here. When we're doing these problems in our homework, make sure you show that. Make sure you show what two perfect squares the number's between, and then circle whichever integer it's closest to. And that's how I'll have you guys do this on your quiz as well. All right, last one here says the distance in nautical miles, or like sea miles, that you can see with a periscope is 1.17 times the square root of h, where h is the height of the periscope above the water. Can you see twice as far with a periscope that is 6 feet above water than with a periscope that is 3 feet above water? In fact, I'm going to fix that. It's kind of driving me crazy. There. So, if the periscope is only 3 feet above water, then that's how far you can see. And if the periscope is 6 feet above water, then that's how far you can see. And so this time we're actually going to use our calculator. It doesn't have us approximate anything. We actually want to use our calculator to figure out what this equals. And then we can see if raising the periscope twice as high will allow you to see twice as far. So 1.17 times the square root of 3 is about 2.026 if I round to the nearest thousandth, and that would be miles that you could see, nautical miles. And then if I do 1.17 times the square root of 6, that's going to be approximately 2.866 nautical miles. So raising the periscope twice as high does not allow you to see twice as far. So you cannot see, S-E-E, not S-E-A, see twice as far.